All right, so let's keep looking at some iOS spyware implants because I think they're a lot of fun to look at. And there's not a lot of them. So looking at a report back in 2019 from CitizenLab, there is a section here related to an implant analysis. And yeah, so I think this is a good one to kind of look into, especially since there's write-ups for anyone that wants to play around with this. It's easy to kind of follow along with these write-ups and do your reversing and make sense of it better. The good thing, they also reference the Google Project Zero report, which is actually here. And I think this is a excellent write-up, both of these. And we're just going to kind of look at the initial, what Project Zero calls the privilege escalation mach-O, and then the embedded implant that's used to like steal a bunch of stuff from an iOS device. Okay, so if anyone is looking at this, there is a specific GitHub repository where they have all their indicators, and within this missing link write-up that they have, I grabbed this hash, and on VirusTotal you can see, obviously this is already known, but this is from back 2019. So we're looking at an old sample, but there's still a lot of value in looking at these. And not only do we have the initial privilege escalation mach-O, which we're not going to dive into that part of it, just more like the embedded implant. We also have the implant in here. So what's interesting is they mention at the top of this analysis, Project Zero, that the mach-O file is inside of this section. So if you didn't already know that, there's a lot that you can learn using the disarm tool by Jonathan Levin for Triage that I'll go over just to have some fun with this. So first thing that we're gonna do, make sure I have my notes here right so I don't forget anything. If you just kind of want to understand a little bit about this sample, you can do like a disarm-I and pass in the file name. In this case, file name is the hash. So again, older sample, still valuable to look at. We have this mach-O. The target OS is iOS 12. We're definitely way past that. But it's still ARM64. So we're good to go because ARM64 is beautiful. And so we have some information there about the file. Cool. If we want to understand like what it might do, maybe we can look at symbol information. So you pass the capital S and we'll see there are no specific symbols here that we can make sense of this sample. Okay, so next, if you want to understand a little bit about the binary as well, you can do a disarm-L and pass this file name. So we're looking at different sections here. And again, we're using the information from these blog posts to kind of tailor our analysis. But if you weren't already doing that, within this output, you'll see something that looks pretty suspicious. So we have obviously the text section, cool, this many bytes related to the text section up here. And then we have the data section. And within this data section, we'll see this file. And we'll see that it's gigantic, bigger than the text section, kind of weird. So that might be indicative of an embedded file if you're looking for that. And you can confirm that using disarm. So if you're not familiar with mach-Os and like the header for mach-Os, similar to like PE files, right? You can look at the header and understand, you know, what kind of file this is. So if you do like a -D, and I'm passing in this again, and just do like a head 5, you'll see the magic bytes related to this being a mach-O. Cool. So now we can also target this specific section and look to see if there's an embedded file in there. Now this is assuming that there's not, that the file itself is not encoded, encrypted, whatever. In this case, at this part of the chain, for execution on iOS, I don't think the malware authors cared about any kind of encoding or anything like that. So we can take a look at that. I'm going to copy paste this from somewhere else so I don't mess it up. Very easy to mess up this command if I don't like write it properly. I'm going to copy paste that. And so it's a disarm dash R. We're passing in this section. I could have just copy pasted that, but that's fine. And then we're gonna pass in the name of the file. Oh, that's too much. So we're just gonna do another head 5. And we'll see, yeah, we can confirm that this is another mach-O that's inside of this data section. Cool. So let's start our analysis with the initial binary and then get all the way up to the point that we're looking at the implant. So we have that open up in Binary Ninja. I have 4 files opened up here. I have some that I've already edited from before just to kind of make my life easier, and then unedited samples. So we have the initial privilege escalation mach-O, which we're not going to dive into that specific portion, just executing the embedded file. And then we have the actual implant here. So let's start here. First thing you'll notice if you're looking at this and you're familiar with like analyzing mach-Os and all that fun stuff, you'll notice that there are variable names here that look like functions that you cannot actually see what these are. But you can kind of assume if you've looked at this before, like the kern.bootargs, like that's CTL by name. This would also be the same, and you can see that these are the same variable name. So there's some kind of dynamic symbol memory relating to different variables that are set up prior to the execution of this. So we can expect something like DLSym or something like that in order to associate the imported symbols to these data variables, and then these are used for execution. So since we can kind of make sense of that all the way at the top, and this looks like some kind of print message, which is pretty funny, we would assume that the first function may be related to this. So the first BL instruction here, branch and link to this subroutine, will be where we would assume to see this association with these symbols and these variable names. And that's exactly what we see. We can actually hover over this with Binary Ninja and already see what's happening. But if we double click into this, we'll see all of these symbol names are going to be associated with these data variables, which will then be used throughout the entire sample. Now there's a couple here that I'm going to make sure that I just kind of edit because it actually has messed me up in the past. So this one, and then the sysctl by name will be in here somewhere. So I'm gonna just wait for that one to kind of pop up. We have the POSIX which will be an important data variable at some point. And yeah, so I just wanted to change one of those. And again, you can just change that here, right clicking, rename symbol, or just use like the quick key for N in order to change it. So going back, we can rename this, right, with N. This is gonna be DLSym. I'm calling it DLSym because it looks like a call to DLSym here. Not really sure what this is specifically, but I see this -2 being passed as the first argument. This looks like a call to DLSym. We're just gonna resolve symbols. Okay, so let's go back. That is going to associate all of these variables to these symbols. So the pointer to these functions is going to be passed in, and then when you see this, it's actually going to branch to that symbol. And you can see that inside of the disassembly here, if we just kind of scroll this over. So we have this, this data variable that's moved into X1, and at the end of this, after we have that data variable that we have resolved, we're actually doing BLR, which is branch and link to register based on that specific address. So that's going to execute that symbol. Okay, so first thing that we have here is this in main, I don't know, NSLog looking type thing. And we can see, we can make sense of this by double clicking on this and seeing where it's referenced before. And if we come in here, we'll see that it's within the resolve symbols function, which we would expect is this syslog call. We can rename that, go back, and now we know that this is going to be a call to syslog, and it's going to just, you know, pass in this string. next call we have here, this looks like a mem set since we have this size. So we can just change this to size here. And we have this address for this data variable. This variable is passed in as the first argument. And if we hover over this, we can see that the code references to this is within the DLSym resolve symbols function. We go here, you see that's a mem set. Okay, we go back. So mem setting, all zeros. We're just clearing up space for this function call, which this function call ends up being sysctl by name. We can see that here. We can actually move this over and it looks a little bit easier to see when you hover over. Sysctl by name. So we can just grab this, go in here, grab this, change this, go back. All right, so call the sysctl by name. And it's gonna look at the current boot args, and sysctl by name is going to, if I remember correctly, man sysctl by name, it should write the return value into the second argument, which will be this. So let's see, sysctl, the information that is retrieved, right? So it retrieves information related to whatever you pass in, is copied into the buffer specified by this, and that is the second argument. Okay, so the return of the CTL by name, which is going to be the boot args, are going to be returned into the second argument here. So this is going to be boot args. Okay, now those boot args are then checked against this stir. So this is like checking to see if these match. Locate a substring and a string. So it's going to look for this IOP114 thing. And I believe that that's related to the implant itself after it actually executes, probably saves this inside of the boot args to indicate that maybe this this iPhone has already been infected or whatever, because it does check for that. What's the return value again? I think it's one of those where it locates the first occurrence in the string. Okay, characters. Okay, so return values. If it's an empty string, haystack, needle, null is returned. Okay, so it's checking to see if it's not 0, and it will then sleep at some point, and we can assume that this is going to sleep based on while true. It's going to run this, right? It's going to run this right here, and this should be sleep. We can see some values being passed in here for 1,000. Okay, and we can look at that and we can see DLSym resolve symbols. Let's change this to sleep. Go back. So this is going to check for this boot arg. So we can just kind of make a comment of this here. Checks, if I can spell, checks for boot args, some random number. You can just make a note for yourself there. Okay, so continuing on, we have more calls to different stuff here. And at some point we're going to get to the implant. It actually does it in a pretty interesting way. So I'll go over that quickly after we look at some of this stuff. So it's going to get this hardware machine. So it's going to get information about the device that it's actually executing on. And it's going to check that. We already know that this is going to return this hardware machine value here to the second argument. And we're going to do another stir against iPhone 6. So is iPhone 6. And there's another stir. If that is equal to 0, it checks to see if it's iPhone 7. Is iPhone 7. Okay. And then it uses this stir copy, which is passed into this, which is then passed into this function. Okay, so I don't know what these are. Haven't looked into that yet, but I know that this is a stir copy. I'm just gonna change it here, save myself a little bit of time. So this value, depending on the result of this if statement, if it's an iPhone 6 or an iPhone 7, it's going to then either put this or this value into this memory address and then pass this to this function. That's pretty cool. So we know that this is then going to do a bunch of other stuff, which we're not going to get into all this right now. This is actually pretty cool. We can see a block is being set up and all that fun stuff. Okay. So it's going to do a bunch of stuff there, and it's going to return something, and then that return value is going to be passed to this function. And it looks like there's a syslog here for some kind of connection that's made. So this is probably going to be some kind of XPC related thing. Actually, let's just go in there just to make sure. Let's see. This function is going to be a mem copy. There's this huge for loop. So let me just change this mem copy. And this, let me see all of this one is going to be XPC connection create mock service. Okay. So now we have some XPC stuff, which will make sense with that specific syslog string that was passed in. So we have for core media, and this must be how it's going to set up the privilege escalation at some point. That's cool. We're not going to get into all that. There's a lot of symbols to resolve here, which would be a lot of fun, and I'm going to try not to get super distracted here because this looks interesting. Okay, more XPC stuff. So I'm just going to rename this into XPC stuff for now, and that's a whole other thing to look at. So looks like it checks for XPC connection. Okay, now we have this function which is going to pass in the return value of that XPC related function call. And what does this do? Let's see if this is the one that, yeah, I'm not going to get into this one right now. Want to get into the implant itself. And I think the implant is probably going to be related to one of these two function calls. So the way that it actually locates the bytes for the implant is actually pretty interesting. So I'm going to go back just for sake of time into the DLSym resolve symbols function, and I'm going to look for where that specific where that was passed. It's like a get section, if I can find it. Section, no. Nope. Oh, get section data. It's pretty cool, I think. So get section data is going to return like a pointer to a specific section in a binary. And this, again, is associated with this data variable. And we can see this address is used within this function. So let's go into this function. And I'm just going to rename this so I don't forget. Embedded implant. Okay. Okay, so this looks like this would be related to a mach-O since it's checking this address, and if it's not equal to this mach-O, it's passing in a size. Okay, that's cool. So we have this get section data call, and we're passing in the data section and then the file related thing for this, and it's going to return it here, and then that's going to be passed into this function. And I wonder what this does. So let's look at what this means. NTOHL. Don't remember exactly how that works. So let's see. Oh, man. NTOHL. Convert values between host and network byte order. Okay, so it's Indianness is what it's checking for. Okay, that's pretty cool. It actually calls this a lot throughout this. But at some point, I believe it actually executes it. So let's go back. to this call. Oh, we got to go back to DLSim embedded implant. Okay. This results. So this is going to be the embedded bytes. Let's just change this so I don't forget. Embedded bytes. If it's not equal to 0, it passes it in here. It mem copies that over. And then let's see what this is. This is going to, this is a malloc for some space. Spell that right. Malloc. And then that mem copy is passed in here based on the return value of this function. And it's going to execute this, which does a mach-VM read. That's cool. So that mock stuff, okay. And at some point we should execute this mach-VM allocate. I think it's down here. Yeah, okay. So we have these embedded bytes. We're not gonna go into the mock stuff right now. We can see down here what looks like a chmod. So we're going to do an fopen for the temp update server file, and it looks like that's where the embedded file will be written to. So we have an fopen. So let's change this here. Again, not going through all the other stuff because we're trying to get to the implant really quickly and don't want to spend a million years here. Okay, so we have this, which didn't resolve, so we can just resolve this really quickly with an A. So we're writing, we're gonna get that file stream. So file stream, and this will be an fwrite. Fwrite. And we're gonna write the embedded bytes to that file stream, and this is gonna be a fclose. And this is like a chmod because we have these permissions being set to this binary here. So chmod. And we have the path to embedded mach-O. And this is going to be a POSIX here. POSIX spawn. Okay, so again, getting the section data, which gets us these embedded bytes. It does a bunch of stuff that we're not going to go into, but at some point it gets down here and it's going to write the bytes into this temp update server, and it's then going to chmod it to execute it, and then it's going to do a POSIX spawn and execute that embedded mach-O. Okay, so again, we skipped a bunch of stuff, but just wanted to get into the implant itself. This has already been going on for a bit. So let's look at that embedded mach-O. The cool thing about this is they're symbols, which is really awesome. You can see a bunch of them in here for different things. Again, at this point of the execution, based on all the analysis by CitizenLab and Project Zero, there's no reason to hide, I guess, what you're doing. So this is all Objective-C stuff, which if you have not already checked this and you're using Binary Ninja, this pseudo Objective-C is beautiful. So it gets rid of all the Objective-C message send. I mean, you can still use that if you want to, but it just adds brackets, which are really pretty. So we have this NSLog for starting, right? So we're just logging out what we are doing. And now it's going to call a bunch of Objective-C methods, and it's going to do a POSIX spawn down here, and we'll get into exactly what it does in a moment. I believe it's here that we start. Yeah. Okay. So we're going to get this NS bundle, and we're passing in, so that's the class, and we're passing in the method main bundle. So there's a main bundle here, main bundle. We're getting the bundle path, right? We're passing in this main bundle, and then using that return value to pass this method for the bundle path. So path. And we have another call to main bundle here. That's interesting. Oh, that's for enums. So n main bundle to, and executable path, exec path. Oh, let me change that, exec path. And last path component. So inside of this huge path, you're just grabbing that last thing, which usually is the executable itself, or is the executable itself. So exec itself. And then we're string by appending component exec itself. So here, exec itself, use suggested name. Cool. And now we are going to reference the UTF-8 string of this exec. So I'm going to call this binary here, binary or mach-O. And this mach-O is then passed in down here. I don't know why they associated that with argv. I guess because of the POSIX spawn call. Okay, so we're going to fork return. If not fork, POSIX spawn, execute that from the main bundle. Okay, so that's not super interesting. What's interesting is what happens next, which is this call here. So let's go in here. We have, again, syslog stuff, which we even have the server information here, which is pretty cool. So we're getting this class, this service shared reference here. So service. And then we have a call to service start. And then service is released. We have this run loop. And we're gonna run this, and at the end of this, release this. So what we really care about is this service start here. So we have to look that up because this doesn't give us something to like click on to go to what this actually calls. This is going to use this resolved service class object and then pass the start function, which will be in here in our symbols. And we have the start, service start here. Okay, so now we can start spending some time on all these little things that it does. I'm not gonna be here forever, but first we have this call to self. So self is gonna be an X0 related to Objective-C, and the selector in this case is gonna be an X1. So we're referencing the service class itself. So we can just change this to service to make it easier to see. And we're passing in the start timer. So all of these will be in our symbols. We can't like double click into where this code actually is. So we'll go into start timer, and this looks like it does an NS timer for something here, stop timer. So it just sets up this timer, which is pretty cool. We're not worried about that. Upload device, that's interesting. So if we go to upload device, we're gonna get this NS log for upload device that we're passing in, and then now we're gonna use this util class, and we're gonna pass this dictionary of device info, which is going to be here, and then we have a call to self for the post files. Okay, yeah, so we'll end there because I think that's pretty interesting. All right, so again, self is service. And we're getting this dictionary of device info. So let's look at this. So dict of device info. And this is going to get a bunch of information about the device, as we would expect. So we have this uname, right? So we're passing in this to get this return value of uname. If you're not familiar with uname, displays information about the system. We're getting information about the device that we're running on, and that's going to be passed in here. It looks like it's missing some information for this string with C string. Here is going to be passed in, and we get the current device. So this is the current device. system version. Using this current device, we're going to get the system version. Another current device, we get the name of it. So current device, and then name. Oh, and if you go back to the Project Zero blog post and you look at the information about this sample, it has the related entitlements to have access to this stuff. Actually, we can look at that. So I think it's disarm -- signature, and then this is embedded or output. Okay, so this is just their signature related information. I want to see the entitlement, so I'm just gonna actually gives you a nice little thing here that you can use. Okay, so that was output. Okay, so here goes related entitlements. It added its hash to, I believe it was like the kernel cache or something, but just gives it the ability to access specific data on the machine. And this is all explained in Google's write-up, I believe. Yeah, right here. Cool. Okay, so in case you're wondering how it has access to all this stuff. Name, copy my phone number. I haven't even seen this function before. That's pretty interesting. Number. I wonder if any of these symbols still work. They probably do, some of them. Cellular is Wi-Fi. Self. Where is self reference? Self is here. Self is util. So I guess it checks to see if it has Wi-Fi. That's pretty cool. Or what the Wi-Fi is, I guess. Or let's see. It looks like it returns a connection type. Oh, it's like what it's connected to currently. That's cool. Then it gets, I guess it uses this information to at some point. Oh, this is how it creates the dictionary of different information that it wants to put together. So phone number, serial number, platform, version, and this is all going to be within a dictionary. And this is going to be the dictionary itself, and this is going to be the key names, which the key names are here. And the values are going to be the values that were passed in from up here. And this is going to be the device info dictionary. That's cool. UUID. So UUID. And then UUID string. UUID string. Okay, so we're passing in temp, and then this is going to be the new path. So temp UUID. And then we're going to write to file. Okay, that's cool. We're using the info dictionary. We're writing to file. We're writing that dictionary into this UUID. And that's going to then be, it's going to be called device.plist, which a plist is like a dictionary in this case, XML. So it has keys and values. Okay, and then it's going to return that value at some point. Yeah, dictionary here, UUID. So this is going to be the return dictionary of this information that it gathered. And it's going to return it, which makes sense if we look at how this was called. Oh, we got to go back this way. Util dict of device info retain. This is going to be the device dictionary. Oh, let me retype that. Okay. And now it's going to do this post files, passing in this device dictionary. Now this is a post files and remove call. So we have two specific methods put together, two different arguments passed in. I guess remove deletes it. That's pretty cool. So we're going to look up service, because this will give us information about the C2, and then we can kind of be done with this one for now. So let's look up post files. So there's two of them, post files and there's post files remove. So let's look at post files remove. Okay, so we passed in, so we have that bool for remove, which is this argument. Post file is going to be the information that we've gathered and we're posting. So we're going to do post files retain. Oh, it actually, it NS logs the files that is going to be posted. That's funny. Okay, so post files, that's fine. Okay, and again, this is going to be service in case we see this called again. And the remove, I wonder where that's, remove is down here somewhere. Not sure how it's used. Probably deletes the files after this. Okay, so if not post files, so if post files is not here, result equals 1. And then this if statement will return that result. So it will return 1. So this returns a bool. Okay, so all keys. So we're going to get all the keys related to this. So keys from dict. And I'm going to get the count of keys. And if that is true, then we do all this stuff. Okay, so let's start here. Now we have some information about some kind of C2, so that's always fun. And we're passing in, we're getting this NS character set, white spaces and new lines character set. Okay, so character set. Well, we're getting this, we're trimming any white space and new line characters by passing in this object as the argument to string by trimming characters in set. So it's just making sure that this is set up right or formatted correctly. So this is going to be our C2. Okay, so now we have our C2. We're now going to set up this NSURL class, NSURL. And we have the C2, we're passing in the string by appending string. So we're going to append a string to that C2, and it's going to be for the upload info path. So upload info C2. Okay, now NSURL string URL with string. So this is actually our NSURL object. So NSURL C2. Okay, NS mutable URL request with URL. So we're gonna pass in this C2 and we're gonna make that. We're gonna set up this URL request. We're not making the request yet. So C2 NS URL request. Okay. Okay, so now we're going to set up the different arguments for this request. We have a post. We have this timeout. We're setting up this NS string to be used for something. Part of the header field. Okay, for the content type. Okay, so retain content type. Okay. For keys, what is this? Service. Okay, keys. So let's put this as keys here. Build body data with params, keys, and files. So we're setting up, and this is going to then check to make sure that that worked properly. So it builds out this body data. NSURL shared session. So shared session. And now we're setting up this concrete stack block, which is always going to be passed in as a completion handler for this type of method call. So we have a call to the shared session, upload task with request. So we're using the C2 URL request, which again has like the C2 in it. From data, completion handler is this. This ends up being a block. and this is like code that you can like pass around to arguments. And then this block is going to then execute a specific function, which will end up being this one. And there's a bunch of other stuff related to this block that it will execute. So this is after the actual URL related session, right? It goes out, it uploads this. You can see that it's going to then check to see its return value, and it's going to probably NSLog if it was successful or if it failed. And that's for the post files function call here, which is pretty cool. So sets this up. This is where it's going to actually execute with the resume. So this is the upload task. So it does that, and it then sets up, it sends all this information about the device up to the C2 server. So that's how that would work. And again, this is just in the upload device section. I would imagine there's probably a bunch of these other types of calls to post inside of other methods for the service class. So we have like request call history, request message, request notes. Again, we have symbols. So we have all the information here that we need to see like exactly how this works. Okay, so I'll close this there. I think this was a really fun one to kind of look at. Again, shout out to those that write really cool blog posts that you can kind of read. Even if they're old, there's still a lot of value in kind of looking at these. And for those that make these files publicly available for anyone to just grab and take a look. There's not a lot of these spyware samples for iOS available, but even from 2019, there's a lot that I learned just kind of poking around. And again, we didn't even go into any of the vulnerability related stuff. This is just like how the first file, ran and then basically grabbed this embedded mach-O and then executed it, which again, this ends up doing all the bad stuff. Even has like locating stuff, which is pretty cool. Location data. All right, well, that's it. Hopefully that's helpful for anyone that's interested in iOS spyware. And I'll catch you on the next one.